Okay, in this one, I'm starting to figure out how to do index buffers. I'm doing index buffers so I can draw everything in. From here, I'm going starting with a simple grid map, but later I'm going to be drawing more complex shapes. And using an index buffer is a lot simpler than using the just the vertex buffer. So this is the first one. It's pretty simple for now. Just a simple grid map, and I've added a sine wave just to show the map moving. The point of eventually it's gonna get more complicated, but for now it's just a grid map. Okay, this is the source code for the index buffer. We have the D3D device, that's our standard library, mathematics for simple math, and the D3D9X. Again, this is more complicated because I haven't really figured out how to put this Direct3D thing into the Visual Studio standard libraries. I don't know what else. Okay, this and I've added diffuse here. That's the FVF. I added diffuse to change the colors. I haven't done the color thing yet, but for now it's just white. But later I'm gonna add colors just to make things interesting. I was planning on it. Okay, we got the screen width, screen height, and mesh width. The the mesh width represents the number of squares, not the size of the thing, not the number of vertices, not the number of corners, just the number of squares. So if we're drawing the the vertices, we need one more. We need one more than the mesh width to in order to draw it. The number of vertices is one more than the mesh width, and one more plus the mesh height time. Yeah, but later we'll see that. Okay, we got the vertex buffer standard, the FVF vertex count. I've added the mesh structure here. It's not really necessary, but just the way to do it. Okay, the FVF, the vertex FVF, vertex count. That's the index buffer object. It's same as vertex buffer. Basically the same, but slightly different, but it's the same. Okay, the number of indices. Okay, note that the index is just a word. We're gonna see that later. That's the mesh vertex. Okay, it's the mesh object for later. And rotation, wave amplitude. This part's not really that important. That's the clock. You need a clock in order to keep everything at the same speed, otherwise it just runs away. Okay, first function, create mesh. We simply create the mesh according to the create vertex buffer standard, the vertex count, index count, and create the index buffer standard. Right, I don't need this. This is not really that important here. Okay, we set all the variables. Okay, just create the vertex buffer, create the index buffer. Second function, draw mesh. Okay, you set stream source. That's for the vertex buffer. You set the stream source, you set the FBF, and that's this part's new. And you use the function set indices to set the index buffer. Index buffer is slightly different from the stream source, from the vertex buffer. It's really not really necessary. So it has its own function, and then you draw the triangles. In my index buffer, I use everything is each tree indices is a triangle. It's an independent triangle. I don't have triangle fans or triangle strip or anything like that. It's just each tree indices is as an independent triangle. Nothing special here. Okay, so that's everything. Create mesh, create mesh, draw mesh, and delete mesh. So you just delete everything. Index buffer, delete the vertex buffer. So the only new thing here is set indices. Once you set it, everything draws the same. Just be careful about set indices. Uh, now, well, set any camera, that's standard. Okay, new world. I just call it new world. That's important. To create the grid, you create a mesh. Yeah, the mesh is the number of vertices is one more plus one more of the mesh width plus one times mesh height time plus one. So it's one more. The mesh width represents the number of squares, not the number of vertices. So it's mesh width plus one plus mesh height plus one. Okay, the number of indices is mesh width times mesh height times six, because each square has will have six indices, two polygons each. Each square has two polygons each, so it's six indices. So everything times six. I'm going too fast here, but whatever. So first you lock the vertex buffer and lock the index buffer. Now to set the vertex coordinates. Okay, now we have a width variable because Now we only counting from the, if we count from mesh width is not the same as mesh height, so the width variable is mesh width plus 1. So for y, for x, so we go for each indices in turn. I equal y times width plus x, so we get the coordinate of each vertex in the vertex buffer. I equal to, for each coordinate vertex buffer, we set the coordinates to 0.5 is the center times the, everything is set to unit. The total width of the structure is just 1, so the middle point times the y divided by mesh width, so it gives you the, it puts everything from the center from center to 0.5. So I just set the coordinates here. This one's too simple, but I'm going to change that later, but that's just the color. Okay, we do the same thing for the indices. For mesh height, I equal width times x. For each vertex, for each number 1 vertex, you set index buffer. Oh wait, so it's three index buffers. So we start. I'm not sure if I can just merge these two. Yeah, just see it. That's a mistake here. I should just merge these two. I don't have to count everything twice. Well, actually I do. Oh, sorry, I do. Because here we have -1, so I do have to do it twice. That's why I did it twice. It's a mistake. I do have to do it twice. So for each vertex, you do 3. You create a polygon of 3 indices: index plus 1, index I plus, that's the left, and that's this corner right here, that's index, index plus 1 is this corner right here, one to the left or the right, and then index plus width equals the one below, this one right here, that's the one below on the left. So from the left to the right, back to the left. 1, 2, 3, that's the first triangle, and second triangle is 1 x plus 1 from the right one down to the bottom right, plus width equals the one on bottom plus 1, the one on bottom plus 1, now the one back to the one on bottom. Everything has to be clockwise. If you do it counterclockwise, it won't display. Otherwise, turn off back face calling a while back. Oh wait, I forgot to indicate this. Okay, set another state, call mode, call none. So we turn off back face calling. That's something I forgot to notice here. I'm going too fast here. Okay, we turn off back face calling, so everything has to be 1, 2, 3. So vertex 1, 2, and 3. So 1, 2, 3. So everything has to be clockwise to the 2 polygons. Now we unlock everything. Okay, for here we clear, draw, set the matrix, set the world matrix, clear begin scene, set world matrix. Here we draw everything. Now that's just for the wave function. Okay, we lock the vertex. Okay, we lock the vertex here, and we just do the same thing that we did before for setting the vertex. Okay, we take the position of the vertex, and for z we set just the distance from the center, well, just the distance from 0 and time divided by the wavelength. That's our wavelength. That's just to do a sine wave, and plus wave t, so that the wave keeps moving. And we set the vertex buffer to 0 to the sine of the distance times the wavelength, divided by the wavelength times the wave amplitude. That's pretty self-explanatory. Now we set the color again. Here I want to change that again, but that's something I'm doing later. Then we unlock the mesh. Very important to unlock. It will still work, but very important to unlock so that everything goes faster. Then we update the clock and increase wave t. Then we draw the mesh. That's pretty simple here. And end scene present. And for end world, we just delete the mesh. Okay, create window, set window probe, do the mouse probe. We change the window procedure, then create the device. I need camera, the world, get the event one world. That's the standard stuff. Every function has this, and we end the world and delete the device, delete everything. Okay, for here we just when you press the mouse button, it keeps mouse coordinate and sets the rotation according to the distance of the mouse that the mouse has moved. so that way everything we can see everything. So that's pretty much it for now. That'll be too fast, but that's pretty simple. Okay, this is the final result. Again, this is a very simple mesh. Eventually, you're gonna twist it to make toruses and different shapes. So this is the start for now.